Okay. So yesterday we learned the introduction of correlation analysis. We learned what are the types of correlation, and in that first we are going to learn Carl Pearson's method. It's also known as Pearson's method of correlation. So, and the first formula which we learned here was, okay, the first formula which we learned here was finding of coefficient of correlation using covariance. So covariance xy divided by standard deviation of x into standard deviation of y. And we have another formula which we will be using, that is r is equal to sigma xy divided by square root of summation x square into summation y square. How do we find x and y? By taking the deviations, that is small x is equal to x minus x bar and y minus y bar. So let's see what are the steps to calculate, then we will go on to solve the problems directly. Okay, so first calculate actual means of the given two series of variables. They will give us two information. Since it is correlation, we will have to find out the relationship between the two variables given to us, and to find out if they are really correlated or not. So we will have to first find the actual means, that is nothing but arithmetic mean, x bar and y bar. After that excuse me. Next, take the deviation. There are little spelling mistakes here. Okay, take the deviations of each variable of x series from x bar and denote them as small x. So we will be finding out x minus x bar and we will be denoting that as small x. Similarly, we are taking deviations from y series and we will denote that as small y. After this, we'll have to square the deviations. Now deviations are nothing but this small x and small y. Now these has to be squared. So x square, y square. So once we square the deviations, next we'll have to find the product of the deviations. Now we will already have the values of x and y. Multiply them, you will get xy. Then you will have to sum up x square. Okay, this is square, they've just put the 2 below. So this is x square, this is x square and y square, and not this here. Okay, and xy. So once we get all this total, then we will be using this formula and finding out the coefficient of correlation. So throughout this process, we would require these three values, which are very important for us. If we find the values for these three here, that is x square, y square and xy, then we will be able to use the formula directly. Okay, let's go on and solve the first problem for you to understand it better. Okay, just hold on a second. Okay, so this is the first problem. Find the correlation coefficient. Find the correlation coefficient between sales and advertising expenditure. So we have two major things. First one is sales and the next one is advertising expenditure. So we have to see how much is both of them correlated, or what is the relationship between these two. So first they have given us sales and then they have given us advertising expenses. So here you cannot take it as individual series, discrete series or continuous series. You just have to see the data and go on and solve the problems. Okay, so first they have given us sales and advertisement. So let us take sales as x and advertisement expenses as y. Now we will take down all these sales and advertisement expenses into a table and then do the further calculation. So here is the table. First heading, computation of Carl Pearson's coefficient of correlation of coefficient. So just the words have been replaced here and there. So we have copied down all the values of x and y from the question. Now once you find x and y, just add them up to get sigma x. So sigma x will also be part of your formula. Then add everything from y, you get sigma y. Now if you observe here, sigma x and sigma y is not taken in a small x and small y. They have considered the capital X, which means we are supposed to find out the small x. Now let's find the deviations from x. Now x minus x bar. Now how to find x bar? This is an individual series. Now to find x bar, median, mode, then other values like mean deviation, quartile deviation, everywhere you will have to consider your discrete series, individual series, continuous series. But when you come to correlation calculations, whatever data is given, just see the data and then go on and solve. Okay, so this to calculate arithmetic mean, this is an individual series. So the formula will be sigma x by n. So sigma x we already calculated. N is number of data. So the number of data is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 number of data given to us. So let's go on and calculate the arithmetic mean. So x bar, I'm only calculating it for x. So x bar is sigma x by n. And the total of sigma x is 621. So I consider that 621 divided by 9, which will give me 69. So that is x bar. Now my x bar is 69. So for at this place, I'm going to replace it with 69 and then calculate the deviation. So let's just replace that x bar with 69. So here x minus 69. Okay, x minus 69. Now we are supposed to consider x, that is 65. 65 minus 69 minus 4. Okay, do not leave out the signs. Consider plus or minus signs. Only in mean deviation you will be ignoring the signs because you have modulus there. Apart from that, everywhere else we will be considering the signs. So 65 minus 69 is minus 4, 66 minus 69 is minus 3, 67 minus 69 is minus 2, 68 minus 69 is minus 1, 69 minus 69 is 0. So likewise, we are going to calculate the deviations from x. Now once you calculate the deviation from x, you have to square them. Squaring is nothing but multiplying the same number 2 times. That is minus 4 into minus 4, minus 3 into minus 3. Likewise, you are going to calculate the x square. So that is the calculations only for x. Now once you calculate the x square, just add up everything. You get sigma small x. Okay, this is not capital, this is small x square, which is 60. So any doubts in the x calculation? So everybody understood the first part. Okay, now let's continue and finish off for y also. Now in y, again the same procedure will continue. We have to first calculate the y bar, that is arithmetic mean. So y total is 612 and we will calculate y bar, that is sigma y by n. N is again 9. So 612 by 9 will give me 68. So the y bar value is 68. So I consider 68 here. So this is going to be y minus 68. Okay. Now we have y values given here. Okay, y values are here. Now 66 minus 68 is minus 2. Then 67 minus 68 is minus 1. 64 minus 68 is minus 4. Likewise, you calculate all the deviations. 70 minus 68 is plus 2. So like this, once we calculate the deviations from y, next you're supposed to square them. Squaring is just multiplying the numbers together. That is minus 2 into minus 2. So that will be plus 4. Minus 1 into minus 1, 1. So likewise, y, when you square them, it's called as y square. So when you add up all of this, it becomes summation of small y square, which is 40. So what are the three major things that we required to solve the formula? First one was sigma x square, then sigma y square, and then sigma xy. So we found the value of sigma x square, we found the value of sigma y square. Now let us go on and calculate xy. Now xy is not multiplication of these two, but the deviations. Okay, you're supposed to multiply these two. That is minus 4 into minus 2, which is plus 8. 3 into minus 1 plus 1. It's like minus 3 into minus 1. So minus into minus is plus. Next, minus 2 into minus 4, which is plus 8. Minus 1 into minus 1, plus 1. So you will have to multiply these deviations from x and deviations from y to get xy. So once we get all these values, we are supposed to add all of them, and once you add them, you get the total value of 33. Okay, 33 is the total value. So we got the three major numbers required to calculate the correlation coefficient. So this is the table calculation. Any doubts in the table calculation? Any part you want me to repeat it again? Okay. So let's continue. Now we just have to put all these numbers into the formula directly. Now the formula goes R is equal to sigma xy divided by square root of summation x square into summation y square. So we know what is sigma xy, that is 33. Then x square is 60, y square is 40. So 33 divided by square root of summation x square is 60 into summation y square is 40. Now 33 divided by 60 into 40 is 2400. Again 33 divided by square root of 2400 is 48.99. Now 33 by 48.99 will give you 0.6736. So that is your correlation coefficient. Now we also saw a chart which gave us how to interpret the numbers. So let's go back to the chart. Now our value for R is 0.67. Okay, 0.67 means how are we supposed to do? 0.67. So which means it is between plus 0.25 and plus 0.75, because our value is between 0.67. So it is between these two values only, which means the data which is given to us is moderate degree positive correlation. So we got positive value of correlation, but it is moderate in nature because it lies between 0.25 to 0.75. So you have to write a conclusion, which is compulsory in correlation problems. In general also in maths paper, it is always very good to write the conclusions. Okay, there exists a moderate degree positive correlation between sales and advertising expenses. So this is what was given in the question, sales and advertising expenses. So we found out moderate degree positive correlation. So this is your first problem. Any doubts in the first problem? Any part of it you want me to repeat? Everybody understood? So let's go to the next problem. So the next problem, there's one more similar problem, okay, which I will be sharing it on the group for you to solve and practice. You can let me know the answers by tomorrow, okay. I'll send it to you later after the class. Now, the next problem, calculate Carl Pearson's correlation coefficient from the following data. Now here again they have given another similar problem only. So here the units are different, that is price and demand. Okay, price is in rupees and demand is in units. So they have made it easy for us to calculate by taking out the thousands units. So let us consider the price to be X and let's consider the demand to be Y. Now we are going to write down all these numbers into the table as it is. Here also we have 9 data again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we again have 9 number of data here. And the first step, as usual, we have to calculate the actual mean, that is X bar and Y bar. So for that we require sigma X and sigma Y. So we will add up sigma X, add up all these numbers, you get 225, and again when you come up to sigma Y, when you add up all these numbers, you get 153. So let us calculate actual mean for both of them. Now calculating actual mean, that is X bar is equal to sigma X by N, 255 by 9. So the X bar is 25, Y bar sigma Y by N, which is 153 by 9, which is equal to 17. So we have got X bar as 25, Y bar as 17. So let's just write down here for our reference. So X bar is 25 and Y bar is 17. Okay, so X bar is 25 and Y bar is 17. So now let's find out the deviations, that is X minus X bar. So X values 21 minus 25 minus 4, 22 minus 25 minus 3, 23 minus 25 minus 2. Likewise, you will have to calculate all the deviations. Next, for Y, Y minus Y bar. So Y minus Y bar is already known, that is 17. So 20 minus 17 is 3, 19 minus 17 is 2, 19 minus 17 is again 2, 17 minus 17 is 0, 17 minus 17 is 0. Likewise, we go on calculating. Here you get minus values on the second half of the table. So this is your deviations from X bar and Y bar. Now the next step is you have to square the deviations. Now squaring the deviations is X square. So you are squaring these deviations which we found, that is small x. So minus 4 into minus 4 plus 16, minus 3 into minus 3 plus 9. Likewise, we will square all the X deviations and call it as X square and add them up. When you add all of the values, you call them as summation X square, which is equal to 60. Next, coming to Y, the similar step we do is once you find the deviations from Y, you square them. So that is called as Y square. And after finding Y square, you are supposed to add all of the values. So you get sigma Y square or summation of Y square. So summation of Y square is 32. So this is the first few steps. So the three major values that we require to calculate the correlation coefficient are summation X square, summation Y square and summation XY. So we already have the first two values. Let's just multiply these two deviations, that is X and Y. Okay, so this column and this column completely if we multiply, we get the values of XY. Be little careful in this problem because you have minus as well as plus values. So minus 4 into 3 will give you minus 12. Minus 3 into 2 is minus 6. Minus 2 into 2 is minus 4. Minus 1 into 0 is 0. 0 into 0 is again 0. 1 into minus 1. If you see here you have minus values. When you multiply it with the positive values, again the resultant is minus. But again, for the next half or the second half, first you have positive values and then you have negative values. So just be careful with the signs. So once you get the values of x, y, now add all of them, you get minus 43. So we got all the three major numbers which was required to calculate correlation coefficient. So that completes our table calculation. Any doubts in table calculation? Can I go on for the formula? Okay. So remember these numbers. Summation x square is 60, summation y square is 32, sigma xy is minus 43. Now let us solve it by applying the formula. Now correlation coefficient formula is sigma xy divided by square root of sigma x square into sigma y square. So that is the formula which we will be using. Now, sigma xy is minus 43 divided by square root of sigma or summation x square is 60 into summation y square is 32. Next, minus 43 as it is, square root of 60 into 32. Now, here they have skipped one simplification step in between, and they have given the final answer. So the next step you can check 60 into 32, that will be 43 minus 43 divided by square root of 1920, that will come. After that we are going to take the square root of 1920 to get 43.8178. So here what we are talking about is, I'll just use the pen here. So this whole expression, that is square root of 60 into 32, this they have simplified it completely to get 43.8178. Okay, then minus 43 divided by 43.8178 will give you a minus value of correlation coefficient. So minus 0.9813. Now to analyze which part of the correlation it comes, now this is minus 1, this is plus 1 and this is 0. Okay, so from minus 1 means it is perfectly negative correlation, plus 1 means perfectly positive correlation. Now our value is 0.98, which means this 0.98 minus 0.98 lies between minus 0.75 and minus 1. Okay, it lies between this place. Okay, when it lies between this place, then it is known as high degree negative correlation. Why negative? Because we have a minus value. So since the value lies between minus 0.75 and minus 1, we can give a conclusion saying there exists a high degree negative correlation between what are the two major things we saw in the problem? Price and demand. Okay, price and demand are the two major things. So we will be considering that, saying high degree negative correlation between price and demand. So this is your next problem. Any doubts in this problem? Everybody understood? Okay. So we'll stop it here for today. Tomorrow I'll continue the class. One more problem will be sent to you in the group for practice. You can solve that problem and let me know the result tomorrow. Okay.